First of all, I want to apologize for cramming so much onto a slide, but this is an addiction test and I want you to have it all in one place. If you say yes to 3 or more of these questions, then you have an addiction, at least according to the American Psychiatric Association. I want to admit that this is slightly abridged. I had to take some things out, and the reality is it's used for substance abuse, not for porn addiction. If you say yes to 2 or less, then you certainly can stop the video and click to your favorite porn site. Let's go over each one. Tolerance, that's a funny word, but it means have you increased or escalated over time? In other words, if you're using porn, have you increased the time you use? Or you could also escalate by going to more shocking or extreme porn. That's another way to escalate. Withdrawal symptoms. Now that's not necessary to have withdrawal symptoms if you have an addiction, but most users on our forum do experience some symptoms. It varies a lot. Could be anxiety, irritability, fatigue, depression. Those are the most common, but some also experience physical symptoms like cold and flu symptoms, headaches, the inability to sleep, and others. Number 3, difficulty controlling your use. So do you use for a longer time than you'd like to? I think that's pretty clear, self-explanatory. Number 4, are there any negative consequences to your mood, to your health, to anything, besides having to watch this presentation, of course? Number 5, are you doing porn instead of life? That's what that means. Number 6, the desire to cut down. Now, most addicts say, I can quit any time, but they don't. If you've had unsuccessful attempts to cut down, that would be a yes to that question. And last one, number 7, spending significant time or emotional energy obtaining, using, concealing, planning, or recovering from use. Have you ever concealed your porn use? Then you'd have to say yes. And I think everyone can say yes to that. Here's a slide on behavioral addictions. It's common knowledge that dopamine-raising substances like alcohol, cocaine, or meth can cause brain changes that lead to addiction. But what about so-called behavioral addictions? Those are such things as food, gambling, sex, video games, shopping. Do they cause brain changes that indicate addiction? Well, of course they do. That's why they are addictions. Recent research on gambling, and especially food, has shown brain changes that mimic drug addiction. Internet porn, no one wants to touch it. No one wants to study it. And it's so recent. Now you tell me, which is more stimulating? Eating cheesecake or masturbating to porn? It's known that sex, masturbation, orgasm raise dopamine levels far higher than does eating food. Which can you spend more time doing in a day? Eating or edging to porn? Let's talk about natural reinforcers. A natural reinforcer is a fancy word for a non-drug activity that causes dopamine release. That includes food, sex, gambling, video games. Now if we look at this slide, it's versus addictive drugs. About 15% or less of drug users, this includes animals too, ever become addicted. Obviously genes are in play, as is childhood experiences. If you look at natural reinforcers, and of course food is a big one, we have a much higher percentage of people who can become addicted, though it takes a lot longer than it would with addictive drugs. Now if you think about it, few people want to be fat, yet in modern Western cultures most people are. Now rats don't care if they are fat, and when they eat Western food, almost all of them overconsume and become obese, not just fat. This suggests 2 things when it comes to natural reinforcers. That our reward circuitry evolved. It evolved to drive us toward food and sex and not drugs. That's why so many people can get addicted to food and internet porn, potentially. And the other thing it suggests is that highly stimulating versions of food and sex can hook us, even when we're not susceptible to other addictions. Here's the question. When can natural reinforcers become addictive? Let's look at this slide. Number one, when they're a highly stimulating version of what our ancestors found really irresistible. Number two, when something is available in limitless supply. Number three, it comes in lots of varieties. That's novelty, of course. And number four, we binge on it without realizing it's triggering brain changes. Now, I think modern food and internet porn fall into all four categories. Both can override our brain's natural satiation mechanisms, the I'm done feeling. And that's because calories and fertilization opportunities really are our genes' top priorities, our limbic system's top priorities. If you have an addiction, your brain has adapted to overstimulation. Here's what all addictions share. Number one, a numbing of the reward circuitry, and number two, rewiring of brain circuits. We're going to go into in-depth in all of these. So if you have a numbing of the reward circuitry, you've messed up your dopamine in some way. It becomes harder to stimulate the reward circuitry, whether it's with food or sex or drugs or rock and roll. You simply feel less pleasure. Now, feeling less pleasure leads to craving whatever will give you more pleasure, and that's often your addiction. Your reward circuitry is basically like a flashlight now, and it has fading batteries. Rewiring of brain circuits. Well, a couple of things happen. First, you get a stronger go-for-it circuit. Go for what? Go for the addiction. You've wired together a bunch of nerve cells that are screaming, let's do that again, let's repeat the addiction. This simply adds to the cravings of the numbed reward circuitry. The more you use this circuit, this craving circuit, the stronger it gets, just like a muscle. In addition, you also have a weaker control circuit. And just like a muscle that doesn't get exercised, this logical, rational circuit that understands consequences gets weaker. You know, these higher circuits know that drinking a bottle of whiskey or watching porn for 12 hours a day may not be the best idea. So with an addiction, it's sort of like tug of war, and the go-for-it circuit is winning. To understand addiction, we need to understand what changes, and that is nerve cells. Most importantly, what changes is the connection between nerve cells. The brain contains billions of nerve cells, and they're connected in circuits or pathways like the reward circuit and endless other circuits. When a circuit is activated, we have a thought, a feeling, an experience specific to those nerve cells. Okay, we're going to get down to the nitty-gritty here. We have a picture of two nerve cells, and they're connected at a tiny little gap called a synapse. See, you have electricity that flows along one nerve cell to the other nerve cell, but it really doesn't. The electricity stops at this little gap, and it causes the sending nerve cell to release neurochemicals, maybe dopamine. And then they go over and they attach to the receiving nerve cell. They attach to places called receptors. Really look at those. Those are going to be important. Now, the receptors are like little ears on the receiving nerve cell, and it can listen to the message that's being sent. Now, there are many neurochemicals in the brain, many types, each with a different message. If there's enough neurochemical released from the sending cell, the receiving cell hears the message and fires an impulse, and then we have an experience. Why am I boring you with all this stuff about the synapse? Why do we care about the synapse, this gap between two nerve cells? Well, this is where all addictions occur, all addictions. Changes here in the synapse lead to a numbed pleasure response and rewiring of the brain. Here's a busy slide. At the top and the bottom we have nerve cells communicating. The red round things are dopamine being released by the sending nerve cells, and they're sending it from other parts of the brain. Now the receiving nerve cells, notice it says reward nerve cells, that's the reward circuitry, and they're receiving the message, which is dopamine. So electricity flows along the sending nerve cells, it's represented in red, and the more electricity coming from other parts of the brain, the more dopamine that's released. So if you look at the top one, you have a whole lot of dopamine because you have more waves of electricity heading towards the reward cell. This would give you greater experience of excitement. This might be like heading towards orgasm. Yee-haw, I don't want to stop. Now, looking at the bottom cell, you can see there's hardly any dopamine being released. This could be after orgasm, where you have no desire whatsoever. So the level of neurotransmitter or dopamine released equals the power of the message. Now, something like methamphetamine or cocaine, you have a huge release of dopamine. Here we are again with reward nerve cells, and we're also looking at a synapse. Now notice the receptors are circled in red. So the key thing is the receiving cell hears the message through the receptors. As I said, it's like ears, or some people say it's like little locks, and in this case, dopamine, the neurochemical, is the key that unlocks things. And when it unlocks things, it causes a message to continue along that receiving nerve cell. Now, if you look at this picture, all 4 receptors are full. That means they're full of dopamine, so it's definitely a go signal. It's a full go signal. And if it's dopamine, you feel good. You need all those receptors to properly hear the message, and that's the key. But with addiction, things change with the receptors. Here we have more reward nerve cells. If you look at the top picture, you have the normal number of receptors. In other words, the receiving cell can hear the message. The reward circuitry can hear it. The bottom group of nerve cells, you have low levels of receptors, only a couple. This is what happens in all addictions. D2 is the type of dopamine receptor that actually crashes. That may not be interesting, but I need to mention that. Now, with overstimulation, the receiving nerve cell says, enough is enough. I can't handle all this dopamine. It's like if someone screams at you, you cover your ears. Well, nerve cells accomplish this by getting rid of their dopamine receptors. In other words, you may have plenty of gas to run the reward circuitry, dopamine in other words, but your engine is missing some of the cylinders, the receptors. Fewer dopamine receptors lead to a numb pleasure response. You can look at the bottom picture and see you have a small effect. You have fewer receptors, and this is what all addictions have in common. Basically, your brain is crying out, I need more dopamine to feel okay, but there's not enough receptors to fully get the message, to hear the message. Literally, there's not enough electricity flowing in the reward circuitry to make you feel okay. You have less pleasure from normal everyday things such as chocolate ice cream or foreplay or watching your favorite TV show. The low receptors leads to other symptoms also, such as being tired, depressed, anxious, irritable. Until someone goes all the way through withdrawal and the dopamine receptors bounce back, they won't really experience normal levels of pleasure. This is one of the main reasons addicts have such cravings. They're looking for something to make them feel good.